Good afternoon. This is Professor David J. De Los Reyes. My topic this afternoon will be Bernoulli's differential equation. Okay. This is now lesson number 28 on my topic differential equation on my channel. So this is actually lesson number D28, differential equation, subtopic Bernoulli's equation. I think this is now example number 3. I will give you example number 3 on the solution of the Bernoulli's equation. Okay, let's proceed, guys. This is another problem. So for those who are taking up differential equations, this is for you guys. The given problem is dy dx equal to the product of y times the quantity x cubed y to the fifth minus 1 closed quantity all over x. The requirement of the problem, as usual, find the general solution. Okay, let's try to bring out the solution. I will try to explain at least possible verbal things for you to understand it easily. Okay. I will write the given differential equation as a solution. Dy dx equal to, the numerator got two terms, so I expand it, then I distribute the common denominator. So this will be y x times x squared times y to the 5 all over x. Y times 1 is y times over x is actually y over x. I place the numerator on the first one to be a product of, this is x cubed, right? So I place it as simply x times x squared because I would like to cancel this one. Okay. So if we try to simplify this one, we put this one on the left. So it will now become dy dx plus 1 over x. This is now plus times y equal to. What remains on the first one is actually y to the first power, y to the fifth power, that's y to the 6th, right? Times x squared. Okay. The resulting equation now is actually a Bernoulli's equation. It is of the form, it is similar to the form dy dx plus p of x times y equal to q of x. For a Bernoulli's equation, there's a y to the n. Because without the y to the n, it falls under the so-called integrating factor. We could solve the problem immediately ASAP by using integrating factor. But since there is a y to the 6, it falls under Bernoulli's equation. And this is actually case number 1. Okay? For Bernoulli's equation, we needed a substitution, but we must have to specify the value of n. The value of n is actually, n here is 6. So I place it here, n is equal to 6. And the proper substitution for case number 1 is actually z equal to y raised to, this is 1 minus n, guys, n. Okay, we are now performing the start of the solution. So solving for z now will be y raised to 1 minus 6. This will become y to the negative 5. Or if we try to eliminate the negative power, we bring it down. So z is actually 1 over y to the 5th power. If we try to cross multiply, y to the 5th will be equal to 1 over z. Let's try to compute for the value of y. Sorry for that one. For the value of y as a function of z, we'll try to eliminate this 5 over here. So we raise both sides of the equation to the 1/5. Left hand side, it will just be simply y, because 5 cancel with this. Equal to 1 raised to the 1/5 is just 1, and z raised to the 1/5 is actually z raised to 1/5. Okay? The z is actually with the positive power. I want to eliminate the fraction, I bring it up. So y is actually z raised to negative 1 fifth. This is now the required relation of y as a function of z. Let's try to bring out dy. Taking the differential of both sides, dy equal to, we'll take the differential of this using power formula under differential calculus. It should be nu raised to n minus 1 times its differential. Negative 1 fifth z raised to negative 1 fifth minus 1 times dz. And actually, if you try to simplify this one, it will become negative 6 fifths. Okay, so dy is actually this negative, right? We bring it down. So dy now will be negative dz over 5. This is 5 over 5. Z raised to 6 over 5. Negative 6 over 5 is actually negative 1 fifth minus 1. Minus 1 is negative 5 fifths. Minus 1 minus 5 is a minus 6 all over 5. So the sum of this is actually negative 6. So we now know the value of y. We now know the value of dy. We place it here. So I place it here, substituting. Dy is actually negative dz over 5z raised to the 6 over 5 times 1 over dx. This is actually dz dx. And this is actually dz times 1 over dx. Okay? So this is dz times 1 over dx plus 1 over x. I'm just following this. Times y. Y is actually z raised to the 1 fifth. Okay? Equal to, the right hand side, it is x squared, right? Times the value of y to the 6th power. But what is y? It is 1 over z to the 1 fifth to the 6th power. If we try to manipulate this one by using algebraic manipulation, these are the expansion. And for the first term to be simply dc dx, we multiply all the terms by 5z raised to the 6 over 5. So if we try to expand this one, what will come out for the first one will be dc dx. Second one is negative 5x times z. The right hand side will be negative 5x squared. This is now the resulting differential equation after the substitution of y and dy. And it falls under case number 2. Case number 2, or number 1 rather, in the solution of a differential equation using integrating factor. So this is actually similar to the form dc dx. This is p of x times z equal to p of x. P of x is actually negative 5 over x. So the integrating factor, required integrating factor for this will be e raised to the integral of negative 5 over x times dx. If we try to simplify this one, it will become x raised to negative 5. This is e, this natural log. So if we try to take the antilog, what will come out will just be simply this one, x to the negative 5. So the required integrating factor for the solution is actually, I will eliminate the negative sign, so it will be 1 over x to the 5. Okay? So the general solution now, for case number 1, using integrating factor, this is z, right? So this is z times integrating factor equal to the integral of q of x, again times integrating factor times dx plus c. Z, what is integrating factor? This is 1 over x to the 5th equal to the integral negative 5x squared times the integrating factor. This is 1 over x to the 5th times dx plus c. If we try to multiply this one, it will just become the integral of x raised to the minus 3 times dx. Okay? Because this is 2, this is 5, what will remain will be x to the 3rd power. We bring it up, it will become the integral of negative x to the negative 3 times x. Power formula. So this should be negative 5. This is negative 2. Negative 3 plus 1 over negative 3 plus 1. So this will become minus 2. Okay. Sorry for this one. Oh, this is just simply minus 2. Right? So, negative, negative, that will now be plus 5 halves, so I will bring it down, x squared plus c. Then try to replace the value of z. What is z? Z is actually 1 over y to the fifth times 1 over x to the fifth, or in simple form, the final answer will be 1 over y to the fifth, x to the fifth equal to 5 halves, 5 over 2x squared plus c. So that's now the general solution of the given Bernoulli's equation. Okay, I will summarize the solution again. We rearrange. What comes out will be case number 1 under Bernoulli's. We got an n to be 6. We computed for the value of z. This is z. Then from this, we will get the relation of y as a function of z, and we could compute for dy. Okay? We will take this value y. Where's y? Oh, this y. And dy, we put it in the original equation. After the simplification, what comes out is actually a differential equation solvable by using differential equation. Integrating factor. And by computing the integrating factor, what comes out is actually x to the negative 5, or simply 1 over x to the fifth. So by following this general solution for case number 1 under using integrating factor, after the substitution, okay, and the integration of the right hand side, we are just lucky the integral of the right hand side is just the power formula, because this is actually negative 5, we bring it out, x raised to minus 2 over minus 2. Because x squared cancel with this, what comes remain on the bottom is x cubed. We bring it up, it will become the integral of x to the negative 3 times dx. So we are just lucky, it's just the power formula. So the final answer is 1 over y to the fifth, x to the fifth equal to 5 over 2x squared plus c. That's the general solution. Oh, that's it, guys. And example number 3 on the solution of Bernoulli's equation under my topic, differential equation on my channel. Good afternoon, Los Angeles.